I want to start not with some academic conversation, but some examples of actual work on instructional improvement that's going on now out in the field. I'll eventually work my way to a few brief comments at the end about why I think these forms of work are properly called a scientific enterprise, and why I think it's advantageous for our profession to take up this term as well as art and craft. Through an initiative we started about a year and a half ago, the foundation is now highlighting the work, has now highlighted the work of 6 different improvement networks that seek to advance ambitious instructional aims equitably for all students. These networks vary widely, urban, rural, and international. They also vary widely in terms of grade and subject matters, from early language and literacy through middle grades math, through work and high school math, and work on argument writing. A prelude, here's the 6 networks. The first 3 are math, and the second 3 are all working in literacy. What the groups are not doing, they're challenging the traditional ways of working, where a district buys a curriculum, offers some professional development, hopes something changes in classrooms, and hopes the end-of-year test scores go up. Although I hate the source of this phrase. So kind of, how's that hopey thing going? And we've just gotten more evidence a couple of weeks ago, a study published by Tom Kane looking at the introduction of new texts in 6 states, and again, failed to lift test scores. So they're following a very different path than the traditional one. So what are they doing instead? The first, each organization has carefully detailed what they're actually trying to accomplish. They've pushed to be very specific about this and to get this down to a very small number of specific intellectual goals. For example, the Better Math Teaching Network, which is a teaching network in the Upper Midwest, took a broad aim, student-centered pedagogical mathematics pedagogy, and converted it into those 3 things. That's what we're trying to accomplish. Likewise, the National Writing Project created an operational definition for what quality argument writing looks like. Again, it turns out to be 3 things: how students select and use evidence, how they distinguish between their own ideas and the sources of source materials, and how well they can judge the quality of the source materials they're drawing on. So first thing, it's a specificity. Because we often start with these global aims, but what exactly is it we're after in classrooms? The second, each of these networks is explicating a set of causal connections about what they think needs to be done to get more of the aims they seek. Each has what we would call a working theory of improvement. In essence, they're opening up what's in that triangle with the question marks and trying to say, here's what we think needs to happen here. Here's an example of it. This is the work from Chile, supported by Oportunidad Fundación Educacional, where they've been working on early literacy improvement efforts in rural Chile. And they've specified 3 primary, what they call primary drivers, that they think they need to work on, as displayed here. And you notice that all 3 of these are right at the heart of instruction. And then they further proceeded to detail out, well, get a little more specific about what is it with regard to each of these 3 things that we think we need to work on as a teaching network together. And then they're in the process of articulating and trying out change ideas to see whether or not they can actually make this happen with some sort of reliability at some sort of scale. Third, they each ask, how will we know if we're really making progress? Along the way, each of these networks, teaching networks, have also had to invent some, often multiple forms of what we would call practical measures to inform the work. Here's an example of the tool that was developed in the National Writing Project as part of their work on trying to improve students' argument writing. This short survey organizes conversations among teachers as they look at student work together. It gives some explicit guidance to students as to what a writing argument should look like. And it provides evidence as this gets accumulated over time as to whether the change ideas that are being tried out in these teaching networks are actually pushing in the right direction. Now, several networks have organized their called improvement theories around a core set of teaching and coaching practices that they view as essential to get a rigorous curriculum to actually work out in classrooms. This information, in turn, is what's fueling these kind of small tests of change, or what are people refer to as plan, do, study, act cycles. Here's an example from the Kip Wheatley network of charter schools in Memphis, that these are the core practices that they're trying to get to occur more regularly across 5 different charter organizations in Memphis. Fourth, they do not assume that just because they've specified the aims and that people are using now new tools and practices, that the work is done. They're living with this haunting question, have we got it right? Their working theories of improvement are generally of a form, and they're kind of these what I would call causal cascades. We're trying to get more of A to occur so that we'll see more of B, and eventually this will culminate in the aims we're after. And sometimes the causal chains are even longer than that. These causal chains represent a group of teachers, educators, current best thinking. But the teams also hold to an improvement mantra, definitely incomplete and possibly wrong. They expect their improvement theories will evolve as they continue to learn their way into work on this problem. 3 years into it now, the work of Central Valley NIC, which is a network of teachers in schools in rural California, Central Valley. Their aim is to triple 5th grade math proficiency. And one of their primary drivers, as you might expect, is they want to improve mathematics instruction. Well, embedded within this driver are a set of hypothesized causal connections. They want to see better math conversations occurring in group work that students are doing, because they see these math conversations as central to students' sense-making about the mathematics they're trying to learn. And then they're beginning to say, well, what do we need to change in the way we organize the classroom activity to get more of that to occur? And one of the places they focused attention on is the protocols that shape the group roles that students are engaged in that are organizing these conversations. So that's you can see the causal logic playing out in their work. And then they're analyzing, well, is this protocol working, and where is it working, and for whom is it not? And when it's actually happening, are we seeing more in the classroom activity of the kinds of things we expect? And ultimately, do we see this in turn linked to the outcomes that all of this is supposed to be pointing toward? So they're analyzing with this whole set of hypothesized connections, which are often tacit. They've now made more explicit. They're analyzing whether these things are actually occurring in their data. And if they're not, they're asking why not. What might we be missing in our working theory of improvement? What might be wrong with the data we're looking at, the measures? Maybe they need to be improved. This deep kind of analytic reflection is at the core of improvement learning. Fifth, this relentless focus on variation in performance. The Chilean network is examining data regularly on the progress of students over time. They aim to get every student school ready. And so they're tracking the literacy development of every student over 2 years of preschool experience. While virtually all of the students, you can see the red on the left-hand side, begin at a very basic level, by the end of the 2 years, virtually all have achieved proficiency. They're also focusing on variation across classrooms. This measure is related to one of their primary drivers on instructional time. And you can see in most of the classrooms there's been improvement from the beginning to the end of the year. And they also have a measure on the quality of the learning environments. You can see change there as well. But there's also still variability. And the existing variability becomes the source of the next round of continuous improvement work. Embedded in this work is a key orientation. Too much remains hidden in average overall outcomes. If you hold as a goal all children prepared to succeed, then you have to be able to see all of the children and all of the contexts in which they're being educated. This is essential if we literally mean better outcomes for every child. Sixth, achieving instructional improvements reliably at scale entails reaching out beyond the classroom. Instructional improvement typically involves aligning everyone's efforts, but not in the traditional sense of from the top down, but rather now more from the bottom up, or put differently, the bottom, the classroom, is now the top. Notice how this is the Kentucky effort, which is a statewide effort on mathematics improvement, how they've organized their work. Professional development is occurring at each level in the organization as new routines and communication protocols are being developed. Each group at each level seeks to improve its own work, better support the people above them, and all are involved in learning together about how the various changes being introduced are working and where and for whom and where not. Everyone involved is a learner. It's quite different from more traditional reforms where most educators are seen as doers and there's a small class of decision makers.
And Tony, just a couple minutes.
I'm getting there, actually. I'm pretty good.
There's only one more number to go, so.
I'm getting there. Seventh, yes. Organizing a hub to sustain the learning. Achieving quality improvement of this type entails complex problem solving. You need a research knowledge base about the subject matter. You need improvement science expertise to support the people engaged in this work. And of course, you need professional knowledge about prevailing practices, local history and politics. This close-in practitioner knowledge shapes how and where to start and fuels the learning as you navigate going forward. Organizing this collective experience, three, took different forms in different places. In Chile, the foundation was the hub of a network. They initially organized it. They assembled the research expertise. They helped orchestrate the learning processes occurring that are active out in classrooms and schools and across the nation. And they consolidate and disseminate the learning that's occurring out in schools so that others can access and make use of it. All the spotlights engaged in some form of intermediary organization to play these roles. Some were local, as in the case of CV-NIC, it was the county office that played this role. Some intermediaries are national, like the National Writing Project and Strive Together. Others had a more organic form, such as BMTN, the Better Math Teaching Network, and Kip Wheatley, that grew up out of the context that we're seeking to work together to improve. The key observation is that few individual schools or districts could make the kind of progress that they aspire to working alone. All right, so that's the example of the organization for the work in Chile, and you can see how they've brought together a very diverse set of expertise to move this all going forward. Okay, so where am I? In sum, all of these networks are working with a set of principles displayed here that we call an improvement paradigm. Formally, this activity has all the trappings of a scientific practice, and the ways people are working together resemble a scientific community. So there is legitimacy in using this term or calling it a science of improvement. Now, I recognize that the word science can be off-putting to educators, and we struggled mightily at the foundation on whether to adopt this term or not. In the end, we finally came down on the side of embracing the term, largely for small p political reasons. Notwithstanding the current DC environment, those who command the term science also command power. Practicing educators, I would argue, should not default, just hand this over to those who study education from afar. In eschewing science, educators would reaffirm a worldview where there's a small class of better knowers and the vast majority of teachers are just doers. This connects closely to a third concern: efforts to professionalize teaching and thereby accord teachers the enhanced status that accrues to professions. A fundamental character of a profession is efficacy in action. When presented with different classes of problems, professions have demonstrated know-how with regard to addressing these concerns. This practical know-how is what improvement science seeks to develop and legitimate. So in advancing this kind of practical knowledge building, teachers are also legitimating their practice as professional. And finally, improvement science moves educators into the position of being active agents in how we better shape the bridge between research and practice. Rather than just waiting for some researcher to come to a teacher or school to say, I want to try out some new tool or idea in your classroom, educators are now actively shaping the problem agenda. This is what we need help on. And they are full partners in the design and development of changes that might actually work, not just in theory, but in real-life classroom settings. So for all of these reasons, I would argue that educators embracing a science of improvement as a core part of their work, not the only part, but a core part of their work, seems very sensible to me.
Thank you so much, Tony. Really provocative and convincing start to our conversation.